Hey guys, we're going to talk about solving quadratic functions today. Don't forget that a quadratic function just means that our highest power of x is squared. So, the solutions for our quadratic functions are where our graph crosses the x-axis. So let's write that. The solutions to a quadratic function are located where the function crosses the x-axis. So these solutions have a couple of different names. So we're just going to make a little note. Solutions are sometimes called zeros or roots. So they're called zeros, roots, solutions. We're all talking about the same thing. And those are the numbers, the x values, where our quadratic function crosses the x-axis. Now, whenever we're doing these, we're going to have three possible cases. We're going to talk about the cases and draw a little sketch. Sometimes your quadratic function has two solutions, which means that our function crosses the x-axis twice. We're going to write crosses twice. So I'm going to draw a little x and y axis here. This is just a random quadratic function. And our parabola crosses twice. And these solutions are located right here and right here. Those are the x values, and those are our solutions or our roots or our zeros. Now the next case is if it has one solution that means that it's only going to cross once. So for this one, let's draw it. Our quadratic function is just going to barely touch the x-axis. So it has one point where it crosses, which is right there. And then the last case is if it has no real solutions. Now, what I mean by no real solutions is that we have solutions, but there are imaginary numbers. And we talk about imaginary numbers later on in the course. So for right now, we're just going to know that there's no real solutions. And guess how many times it crosses? None. So, doesn't cross the x-axis. So let's draw that. So we got a little x and y axis. And this is something, boom, it never touches that x-axis. So that's what happens when we have no real solutions. Okay, so we're going to talk about a couple of different methods on how to solve these quadratic functions. The first way we're going to talk about is graphing. Now we're going to use your graphing calculator to graph these solutions. Now I have a video that I'm going to pull off of YouTube so that Miss Salufo can show you. and it shows you the steps on how to type it in the calculator. So she's going to show you that now. Well, let's do a couple of these examples together. And quite frankly, I think that the Polynomial Simulator app is absolutely wonderful with solving these. So we're going to call this example 1. And our directions say solve using the calculator. Or solve by graphing. So you can use the first method that they talked about in the video. Or by the calculator. And once you figure out how to use the Polynomial Simulator, it's actually pretty easy. So the first one we're going to look at is 2x squared plus x minus 21, and that's equal to 0. Now, if you want to use the graphing piece, you go to your y equals, and you're going to type in that function, press graph, and when you take a look at it, we're going to see that we've got 2 solutions because it crosses the x-axis twice. So now I need for you to press second calc, go to 0, which is number 2. Then you've got to do this twice. You've got to find the left solution and the right solution. So do this now. Once you find your zeros, it tells you that you have, our answers are negative 7/2 and 3. The negative 7/2 is actually written as a fraction. As a decimal. So it says negative 3.5, which as a fraction is negative 7/2. So if you're using the Polynomial Simulator, press apps, and on our calculators it's option number 9. Press enter, and we're doing number 1, polynomial root finder. We have our highest order of 2 because we're doing quadratics. We want real solutions, fractions if we can get them. So just press next, and we're going to type in the A, B, and C. So A is 2, B is 1, and C is negative 21. Then press graph, which solves it. And it tells us that our 2 solutions are negative 7/2 and 3. So next, let's try this one together. We have x squared minus 6x minus 7 is equal to 0. So pause the video and try to find what the solutions are, or solution or no solutions, of this quadratic function is. So we find either using the method of graphing or using the simulator app that our answers are 7 and negative 1. Let's do 2 more. Let's see, we have negative 3x squared plus 5x minus 3 is equal to 0. Pause the video and try to find the solutions to this quadratic function. So once you put them in the calculator, your answers, what did it pop up and say on the Polynomial Simulator? It said no real roots. And if you take a look at it graphed, this function actually does not touch the x-axis. So we don't have any real solutions. We actually have imaginary solutions, and we'll talk about how to find those later. So one more. Let's do 4x squared minus 4x plus 1 is equal to 0. Pause the video and see if you can do this one. What did you guys get? I got one solution of 1/2. Now, if you take a look at the picture on your graphing calculator on the graph, it only touches at positive 1/2. And also, if you use the simulator, it tells you that x1 and x2 are both 1/2, which means there's really only one solution. So now we're going to talk about a different method. We're going to talk about the quadratic formula, which you all have done quadratic formula in Algebra 1. Now, you might have learned a little fun song or some way to memorize the quadratic formula. It's very beneficial to have this in your head, especially when you don't have a calculator handy and another method doesn't work. So let's go ahead and start off by writing the quadratic formula. So given a quadratic function where we have ax squared plus bx plus c, which is our standard form for a quadratic, we're going to extract the a, b, and c from our formula, and we're going to plug it into our quadratic formula. So our quadratic formula is negative b plus or minus big square root b squared minus 4ac all over 2 times a. Now, there's something I want to point out. A lot of things are going to depend on what b squared minus 4ac is. So let's talk about b squared minus 4ac. So we're going to say if b squared minus 4ac is, and we're going to have 3 options. If it is positive, we have 2 solutions. If it is 0, we only have 1 solution. If it is negative, we have no real solutions. So as we're doing these, we're going to talk about what b squared minus 4ac is and how it will affect our solutions. This is actually called the discriminant. The discriminant. Let's jump into some examples where we're going to use the quadratic formula. So this is example 2. And our directions are solve using the quadratic formula. Okay, so the first one we're going to start out with, we're going to have x squared minus 2x minus 3 is equal to 0. So in order to do this, we want to take a look at the coefficients in front of our x's as well as the constant. So we're going to extract out our a, b, and c. So our a is whatever's in front of x squared. And remember, we can always write a 1 there. So our a is 1. B is going to be negative 2, so this sign needs to come with it. And C is going to be negative 3. Now we're ready to plug in the formula. I'm going to rewrite the formula so that we can have it handy. Negative B plus or minus big square root B squared minus 4AC all over 2 times A. So let's plug into this guy. So we have the negative from our function, but then we also have a b that is negative 2. So we got to practice safe parentheses, and we put negative of our b, which is negative 2, plus or minus big square root, use some parentheses, we have negative 2 squared, minus 4 times our a, which is 1, times our c, which is 3. And this is all over 2 times a, and our a is 1 in this case. So we need to be really careful when we're cleaning this up. We want to first take care of everything that is underneath the radical, make it pretty, and then we're going to go from there. We can go ahead and do little things like take care of the signs here and multiply these out. But we're going to handle this guy at the last minute. So negative of a negative 2 is a positive 2. Then we're going to have our plus or minus. We'll deal with you later. And so negative 2 squared is 4 minus 4 times 1 times 3. Oh, shoot. What did we forget? We need to plug in a negative 3 here. See right here? So we have 4 times 1 times a negative 3. Sorry, kids. I was getting ready to say that wasn't going to turn out right. So we have negative 4 times 1 times a negative 3. That's positive 12. That's much better. Then we're going to put it over 2 times 1, which is 2. So the last thing we need to do is underneath our radical, we need to take care of 4 plus 12. So that is 2 plus or minus the square root of 16 over 2. Now, we know what the square root of 16 is. The square root of 16 is 4. So I'm going to rewrite this as 2 plus or minus 4 over 2. Now, our b squared minus 4ac happened to be a positive number. So that's going to tell us that we have 2 solutions, 2 roots, or 2 zeros, whatever you want to call them. So now we've got to figure out what those 2 are. What gives us our 2 solutions is this plus or minus sign right here. So how we're going to write our 2 solutions, I'm going to come up here so I can have some more room. So we have 2 plus 4 over 2, but also we have 2 minus 4 over 2. So we have to write it with the plus, and then we have to write the expression with the minus. So 2 plus 4 is 6 over 2, which simplifies to 3. That's one of our solutions. Then 2 minus 4 is negative 2 over 2, which is negative 1. So our 2 solutions are 3 and negative 1. And we're done there. Let's move on to another example. Let's take a look at 2x squared minus 4x plus 1 is equal to 0. So the first thing we want to do, we want to pull out our a, our b, and our c. So our a in this case is 2. Our b in this case is negative 4. And our c in this case is 1. So from here, let's go ahead and plug into our formula. I'm not going to rewrite it. We can put it on the board and reference it if we need to. We have a negative from our formula of a negative 4, which is our b, plus or minus the square root of negative 4 squared minus 4 times a, which is 2, times c, which is 1. Been really careful with our signs this time through, right? Over 2 times a, and a is 2, so 2 times 2. So let's clean up under a radical, change our signs around for the 4, and do our multiplication at the bottom. So we have positive 4 plus or minus the square root of negative 4 squared is positive 16 minus 4 times 2 times 1 is 8 all over 4. So let's go ahead and take care of 16 minus 8. So we have 4 plus or minus the square root of 8 over 4. Now at that point, we don't know what the square root of 8 is, but that's okay. We're going to be able to leave our solutions as decimals for the time being. We're going to revisit this when we talk about radicals. Now, here's the point where we need to write both of our solutions. I'm going to come up here to have some room. So we have 4 plus the square root of 8 over 4. Then we also have 4 minus the square root of 8 over 4. We can put those in the calculator. And for the first one, we get a positive 1.707. Let's use 3 decimal places. And for the second one, we get a positive 0.293. So our solutions are 1.707 and 0.293. Okay, there we go. Now we're going to do one more. We're going to do x squared minus 4x plus 13 is equal to 0. First thing we want to do, pull out our a, which is 1. Remember, we can write a 1 here. Our b, which is negative 4, and our c, which is 13. So let's plug into our quadratic formula. We have negative of a negative 4. So we have the negative from our formula, and then we have our negative 4 for our b, plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is 13, all over 2 times a, and a is 1. So let's clean up under the radical, take care of our signs in the front, and multiply their 2 times 1. So we have positive 4 plus or minus the square root of negative 4 squared is 16. Then we need to multiply 4, 1, and 13, and we get 52. All over 2. So let's finish cleaning up under our radical. We have 4 plus or minus the square root of, and we get negative 36 all over 2. So here's where we can actually stop. Because we have a negative underneath our radical, we are not going to have any real solutions. So we're going to say no real solutions. And we're going to stop here. We're going to talk about what it means to have no real solutions later on in the course.